Good morning, all. Say good morning loudly. Thank you. Okay. See, it's always, first of all, thank you for the opportunity to be with you all. See, I'm seeing me in you all. So, I'm very sure that you people will take yourself as well as the country to the greater heights. So it's a promise you have to give me that you will do your best and improve yourself as well as the country. And if you take any society, two things which deter any society as well as the individual's development or as well as the country's development, it's one is the poverty and the other is the ignorance. So education is the tool to eradicate ignorance and thereby we can uplift our society. See, post independence, our country was fighting against poverty, and now we are we have developed from a poor country to a developed country and hope soon we will be a developed country. So, since education, it's actually a tool to to improve your critical thinking, to improve your personality, to take away your ignorance. See, the knowledge is the main thing which makes you be not an ignorant person. That gives you, see, because of ignorance, the fear comes in you because of ignorance. Once you are if you understand the things and your fear will go and you will blossom into yourself. So it's always keep your eyes and ears open. It's more than the school, in the school, more than the studies, your peer interactions and your observing the things will make you a better person and it will help you in coming out of your ignorance and fear and you will be a better person. So that the education is a tool for your improving your critical thinking and the innovative skills and thereby and your inculcate a temperament, scientific temperament. See, science is the basis through which the science and technology is very well related. Science, if you see, from science, if you take now, you might have all read and studied that it's a fundamental Newton's law of motion, if you take, and Faraday's law of electromagnetism and Kepler's planetary motion, and the famous Newton's relativity is, these are all the basis laws which made which governs the aerospace engineering as well as the spacing. These are all the basic laws through which we develop the technology. And technology, if you take all these laws, which helps us to understand the evolution of the universe, that cosmic process. And this science gives you insight, which makes the technology to develop tools. So in turn, the tools what you develop in technology will feed back to science. So thereby it's a circle, science, technology, and with the education, science, technology, and that in turn all together will improve our economy. So they are playing a direct role in our economy, thereby we can get rid of the poverty. So education and the science, that scientific temperament will be the basic requirement for a development of the country. And if you see the semiconductor, or it all started from the Neil Bohr's atom. He found out that atom exists, protons exist, electron. From there it started the semiconductor technology. And today, see, when I joined ISRO, it was like the one computer means it will be occupying a huge room. You people might not have a chance to see that type of computer. It will be a huge room. Now that same room computer is in your hands as a mobile, as a laptop, as a notepad. So that's the technology which developed. But it's all started from the fundamental science, which is from the atoms theory. And see, like this, and that is the most important invention of the century and the computers, and now slowly we are moving towards the quantum communication, optical communication, and everybody would have heard of artificial intelligence and machine language. So that is the way it goes. So as we grow, but finally as we grow, as we develop, as we use more and more technology, that means we are fast depleting the resources of earth also. So now that's why there is lot of concerns of climate, as you were aware, because of all this growing. Our waste management is not proper, and we use lot as the comforts increase, as we deplete the natural resources, we are moving into another way of short of resources. And now the need of the hour is the sustained development. We should use the natural resources less and use again the technology comes handy to have this sustained development also. So when you are studying, be focused on the fundamentals and learn fundamentals thoroughly, over which anything during your any lifetime you can build things over that. And also learning is not going to stop with the school or college or by profession. It's a lifelong process, and you please continue be a learner, because in Tamil there is a saying, கற்றது கையளவு கல்லாதது உலகளவு. So that you keep it in mind. What we learn, what we know is very small and tiny, and what we don't know is a huge like sea. So better always be a learner, be a learning process. And it's not science alone, because we need all walks of life for a holistic societal development. So keep whatever you are passionate, whatever you do with commitment, sincerity, and be passionate. See, if, in ISRO there is a culture. Everyone feels that whatever they do is their pride. We take pride in what we are doing, and we are very passionate about what we are doing. So I think these are all the two things which gives us more success as ISRO and to the country. So my sincere advice is to be passionate and sincere of what you are doing, and put not just dreaming or passionate about something is not sufficient. You have to put a very hard work. So hard work never fails you. So I definitely wish you all in your future endeavors. Just being in space, I just want to tell about space something. So why space is challenging, what way space is different. So what we see is, it's like Earth. In space we don't have an atmosphere, it is totally vacuum. And the temperatures, if you see, it will be very hot to plus 200 to minus 200 it will be. And also we'll have, because as you know, sun, see, that's why we have Aditya mission, that it continuously ejects that radiations and the ionized particles that will be hitting the spacecraft which flies above the atmosphere or the interplanetary one, because this galactic particles and the sun particles are flowing continuously, and we need to protect our, if we have a spacecraft in space, we need to this hostile environment of vacuum, temperature, and radiation. These three things has to be protected. So that's how we build the spacecraft which can withstand or protect it from the radiation, vacuum, and the temperature. And one more thing is that the most important thing is, it's always remote. See, like if you take a car, so if you're on the way when you are riding, if it has a problem, you can immediately open the bonnet and see what is the problem and repair it. But in space, it's all remote. We get few status of all the systems through remotely, through as a through RF signal we will get. From there, we have to assess what may be the problem and how we have to do it, how to direct it. So all those things has to be done totally remotely. And so space is also one thing which is quite unpardoning. So we need to do lot of tests. See, actually if we take our one project development, 40% is our design and 60% is the testing. And also if you take Chandrayaan 3 or Aditya, see, we need to test a lot of things because in moon, the gravity is 1/6 and it is, there is no atmosphere. So we need to test the systems to suiting to that conditions, and also we cannot simulate the entire thing. Suppose, see, in the Chandrayaan, if you take, we have to fly from 30 kilometer and we have to kill the velocity by the time it reaches the ground to 0 kilometer per second. So this entire generation or entire test we cannot conduct at Earth. We need to conduct in a portion of it, or we have to stitch it further. So it's always not that exactly we will not be able to. That's why in space failures are more. We will not be able to simulate the entire thing always actually in ground. So how well we anticipate the failures, and that's how the project will be successful. So this is the basic difference of what we do in space to what we do at Earth. So that makes it so challenging, and I'm really, really happy to be part of this ISRO, to have an opportunity to do such this niche area of space science and contribute to contribute my whatever I can contribute towards that. And it is a big team effort, because if you take an Aditya L1 project, maybe some 200 to 300 people will be working on that. We have separate teams for each branch of engineering, and they will be doing what they are supposed to do. That's how it's a big team effort, and it's really nice to work. See, I always feel morning going to office is I'm going there to do my hobby. That's how I feel. So that gives me a lot of pleasure in working, and wishing you all the very best for all your future endeavors. Thank you.
Thank you so much, ma'am. Thank you for your inspiring speech. I hope the young aspirants would have noted it. And without further delay, let's dive into this unique opportunity to interact with the beloved ma'am and learn from the insights of her. Welcome to the interactive session, and let's make it a memorable one and exchange of ideas and experiences. Over to ma'am. First question from the school, Devi Academy. I request Devi Academy to raise up and ask the first question, please.
Namaste, ma'am. This is Academy School, and I would like to ask you a question.
Yeah, please.
How does ISRO help in the public and educational institutions to promote space education and awareness?
Yeah, see, we have a program which is called, I'm not getting the name, because we conduct normally in the month of January, and we will normally publish in our website that we we will conduct a test for the school students of standard 9 and 11 all over India can participate, and the selected students, which may be around 50, can attend a 2-week residential program at ISRO, and we will give you an overview of what we are doing, some hands-on experience, some visits to our labs, and so you can have, that's one program we have got. Apart from that, we can visit our centers. Anytime you can write to our URL of satellite center, and as a school team you can visit and have just an awareness or a visit to our facilities. And also during our what we do is we celebrate normally October World Space Week. So during that time, our scientists and engineers will cover all over Karnataka to all the schools, and they will give an awareness of our programs and things. And also we have National Science Day. We celebrate February 28th. That's Vishweswaraya's birthday. So that time also we conduct a lot of competitions for the entire Karnataka schools. But similarly, each center, we have centers all over India. So each one will be covering some of the states around it. So this is the only way we interact with the students. Apart from that, the colleges they can have their internship in our centers. PG people can do a 6 months project work. They can apply and do the project work. And we have also some programs with the institutes can respond to our requirements of problems. So that way we will fund them and they can do some work for us. This is how we interact with the academia.
Can we give a big round of applause? Thank you, ma'am. Thank you for the answer. Next will be RMK Senior Secondary School. Can you please ask your first question? RMK Senior Secondary School.
Hello ma'am, this is N.D. Durkeshwar from RMK Senior Secondary School. So here is my question. So Aditya L1 was being launched abroad by the PSLV C57. So the first PSLV was developed by IRS into the sun's synchronous orbits. So what are these orbits referred to? And is there any particular purpose for sending the Aditya L1 into this orbit, into this particular orbit?
No, actually we have, normally the satellites we have is, one is the sun synchronous or low earth orbit. The sun synchronous is why it is means that the orbit, no, it moves with the sun. See, every day you will get the sun's inclination at local time same. So that is the characteristics of the orbit that precedes with the daily rotation of the earth. Another one is we can have lot of low earth orbits with a particular inclination. See, some of the signs they require particular. Again, the inclination is defined by which is the area what you want to observe on earth. You know, earth there are latitudes and longitudes. So as the latitude, because when spacecraft goes in an orbit, it can have cameras which can see a particular portion only. It cannot see the entire earth. It doesn't have the field of view. So that's how we define the orbit. Depends on the application. We'll go for sun synchronous. Then the vehicle is not defined by the orbits. The rockets are defined by their carrying capacity of the payload. So PSLV can carry 1500 kg spacecraft only, and that also it depends on higher orbits, the mass will become less, and when it goes to lower orbit, mass will become. And for the communication satellites, we have a geosynchronous. That is, you need always, it will be seeing the earth. It moves with the speed of rotation of the earth, the orbit. So it always is that the lower earth orbit will not see the same place, see the place always. It will be for a particular time it sees, and again next day only it will see the particular space. And so this is how the orbits are done. Apart from that, Aditya and all, it is an interplanetary mission. It leaves the Earth's sphere of influence and it travels along as like Earth, it orbits around the sun. It orbits around the, finally it will get inserted in the means it will be pulled to the attraction of the other planet. So these are all the various, depends on the application, we'll have different orbits.
Happy morning. Happy morning, ma'am.
Yeah,
This is
morning.
Ramana of grade 8 and here is my question. How does Aditya Solar Wind Particle Experiment aspects and in situ payload installed in Aditya L1 finds or rather analyzes solar wind particle protons and heavier ions with directions? How does it help in the research ISRO is conducting?
Yeah, this we have in Aditya imaging payloads as well as the in situ. In situ means it will directly, so you might have heard that from the sun, lot of ionized particles will be traveling, hydrogen, helium ions and all. So this is mainly these aspects, whatever you are telling, this instrument is to measure the direction of the particle, the speed of the particle which it comes. So mainly it is to give a warning that later, it is to develop a space weather model later if there is a solar storm or something is coming, that depends upon the intensity and the helium and hydrogen ions ratio, the direction, it's all done by the electrostatic analyzers. So they calculate that and so at any point of time they will be able to tell that at what velocity the ions are streaming from the sun and what direction it comes. Is it in the direction of the earth, or because as the sun rotates, it's only in particular way it comes only, it will be hitting the earth or above the spacecraft which is orbiting around the earth. So this is an instrument which does those measurements.
Thank you.
I request all the parents to be seated, please. It's a lifetime opportunity to have an interaction session with ma'am. I request the audience to be little more patient. Next will be Present Vidya Mandir, Senior Secondary School.
Coming from Present Vidya Mandir. Ma'am, it is said that in 5 billion years, the sun will eventually lose its energy and it will grow out of its stable phase. Will Aditya L1 do any research about this? And ma'am, also, the Aditya L1 is neither close to sun, it is just 1% of Earth and sun's distance. Then why it is actually named as Aditya?
No, it's first of all, it is named as Aditya because in Sanskrit Aditya means sun, and this spacecraft is studying about the sun. So it is named as Aditya, and it is going to be around the L1 point. That's why it is Aditya L1. L1 is Lagrangian points we call. You can go back and refer it to your mobiles and internets. It's a point where the sun and earth gravitational pulls will be balanced. It will be almost zero at that point. So you can have a spacecraft, it will act as an imaginary planet, that point. That point is 15 lakh kilometer from earth, and total distance of sun earth is 150 lakh kilometer. So that's how it is 1% closer to the sun. So it is, that point is, the beauty of that point is that point travels with the earth. So always the spacecraft which is orbiting around the L1 will have an opportunity to see the sun 24/7. So it moves in the earth and there is no occultation or there is no disturbance from any other thing. So always, so that is the advantage of that point. So it is to study the sun. So at L1, so that's how it is named as Aditya L1. And any solar system, it's like, you know, no, in our Milky Way galaxy itself, billions of solar systems are there. This is what we exist here is one of the solar system. This solar system always, it is second generation star we call it. So this has, but how it is the hydrogen helium fusion what is happening in the sun which gives out energy and light. That's how we are existing today. So anything, there is a finite amount. So in sun also there is a finite amount of helium and hydrogen. So this is what is expected at, it lasts for only 10 billion years. So by that time that all the hydrogen helium will get exhausted and the star will go to the dying state of dwarf, and it will become a black hole, and it will either become a black hole or supernova or something. So already we have crossed 4.6 billion. So we have life again, the remaining 10 billion.
After the continuous launches, the silicon demand has soared. Can carbon nanometers and silicon chips and graphene chips can prove to be a better
Use in that structural materials presently, and it is a candidate for semiconductor technology to have our chips, and but the work is going on. Still it is not very full-fledged where we can manufacture something. So that's going on, and it is a great candidate for the semiconductor.
Check. There is this equipment called solar coronagraph. I would like to know the usage of this equipment, ma'am. And I am very, very keen to know if there are upcoming missions where we'll be using more such equipments that will be great for our use, ma'am, in ISRO.
Can you repeat which instrument?
Solar coronagraph, ma'am.
Coronagraph. Okay. See, that is a major instrument in Aditya L1. The coronagraph is normally, you know, when you have sun eclipse, Surya Grahanam you might have seen. So that time only you can see the sun will be eclipsed by the moon, and you see the outer ring. Outer ring of, that is the atmosphere of the sun is called corona. That expands vastly to the entire, because we don't have an exact measurement, or it cannot be confined as this is the width of the corona or anything. So whatever the outer atmosphere is called the corona. So here from Earth, if you want to view that, only in eclipse time you can view. So what this instrument does is, it internally we have optics which puts around, which takes out the, that there is like one occulter that masks the center of the sun, and only the outer whatever is coming out, that it's actually, this instrument is a imaging instrument that images the corona in visible as well as IR band. Okay, so it is mainly to study about the coronal mass ejections which happens, and also the magnetic field what is in the sun. For all those things, this instrument we use.
Thank you, ma'am.
Over to Prasanna Vidya Mandir for one more promising question, please.
Ma'am, I have heard that Parker Solar Probe, which was the mission done by the Applied Physics Laboratory, reached a very long distance towards the sun. Then why didn't ISRO aim towards the sun? There is so many benefits in pointing the space towards Lagrangian point. And what is the uniqueness, the gravitational equilibrium for the Lagrangian point, ma'am?
No, the uniqueness in the sense, that's what it acts as, because it is almost balancing and it will be a low gravitational pull point. It acts like a moon or a Venus or any other planet. It is like an imaginary planet. See, around any planet we can have a spacecraft like that. This point, and also as I explained, it has an advantage 24/7 we can observe. That is the uniqueness of the point. All the solar studies normally they do at this point. And talking about solar probe, that is a mission which which has gone. That is the mission which has gone till now very close to the sun. But very close to the sun means it's also like 20-30% of the sun. But it is not orbiting around the sun. It's just makes a flyby and do the measurement and comes back. Because going closer and closer to the sun, you should have good thermal protection system, because the temperature is very high. You should have a thermal protection system which can protect your spacecraft from that technology we don't have till today. So we are in the process of developing. So that's why we go here for the study, and mainly our goal is different than the solar probe. So that's how we do it here.
Thank you, ma'am. Next, we have Ritik of Jain Public School.
Studying in Jain Public School, there are so many galaxies in this universe. Is it possible to find all of them? If so, when and how can we find all of them?
You're asking about life,
No, ma'am, galaxies in the universe.
galactic neighbors.
No, galaxies in this universe. There are so many of them.
Yeah.
When and how can we find them? And is it possible to find them?
No, it's possible, because anything is possible. As the technology, you don't know. Yes, some 50 years back, you would have never thought we'll have all this technological development. So, the course of time, it can, because presently, what we are, so the Voyager 1 and Voyager 2 are all the missions which had traveled or crossed our Milky Way galaxy. So in the galaxy itself, we have thousands of millions, billions of solar system. So it's possible to image or observe. And also we have lot of missions which try to identify, is there any possibility of life in any of these systems. It again depends on as you go far and far, and your the signal strength, what you get, because as the light years of, if you say that our nearer neighbor Alpha Centauri itself so many light years away, it takes maybe some years for the light to come and reach Earth. So we are trying to, there are a lot of probes we are studying, it's all by imaging. And over the years, first of all, the thing which is limiting us to going further and further is the propulsion system. We need to move that propulsion, and the propulsion what you can carry from a rocket is limited. So that's how everything is limited, and whole world is looking into alternate propulsion system, nuclear, because this Voyager 1 and 2, if you see, it's all because of, and also there are many techniques without propulsion, using the gravity of the planet itself, we can move forward. So it's, we are into this, all these things. So one day we may reach your other galactic new also.
Thank you, ma'am. Last question from Devi Academy.
Good morning, ma'am. I am Pooja Karishma from Devi Academy. My question is that if a wormhole were to connect two regions of the universe with different physical constants, what consequences might this have in the laws of physics as we currently understand them?
No, can you repeat? I'm not.
If a wormhole were to connect two regions of the universe with different physical constants, what are the consequences might have for the law of physics and we currently understand them?
I'm not very I don't have a much hold on this wormhole, but it's for connecting two regions of the universe. That also people are studying to utilize it, as I explained, that without propulsion, how to use the natural way of computing. So that is on the study. I don't know much about that wormhole, but as you, that laws of physics or anything, see, it's keep changing. See, today, whatever the laws, what we govern, some of the laws won't change, but tomorrow, with the more understanding, more finding, more validation, we may challenge it. So once, you know, we understood that Earth is center and every planet is moving, that was the law of that day. So by our science and findings, we have later understood the sun is center and everything. Like that, it's always, change is inevitable with the validation and inventions. It's one day it will be challenged also.
Thank you, ma'am.